Question 6. I've put one like this on the homework sheet, one where you've got the function defined in two parts. If it's been defined in two parts, it has to be defined for all the numbers. If you look at g of x there, it does one bit when it's less than 4 and another bit when it's greater than 4. It doesn't tell you what happens when x equals 4. And so this one is not a function because we don't know what happens at 4. So f of x does work though, so let's have a look at the graph of f of x. It starts by doing a 4 take away x graph. 4 take away x would be a diagonal line going downwards, going through 4 here, and going to 4 there as well. But we only want the bit that's less than 4, so we don't want any of this bit here. And because it's less than, not less than or equal to, I'm going to put an open circle at that point there. Because at 4, you put 4 in the other part of the function. So that's 4 squared, 16, add 9 is 25. So actually, if you've got 4, you've got the value 25, which is up here, and then it's then continuing on as a quadratic curve going up and up like that. So the graph, weirdest graph you've ever seen probably, looks something like that. We've been asked to find out what f of 3 is. Well, 3 is less than 4, isn't it? So we're just doing 4 take away 3, and so the answer to that bit's 1. If we're doing f of 10, well, 10's bigger than 4, so we're doing that in the squared part of it. So that one gives 109. And now we're asked to try and find out, well, what would it be if it's going to equal 90? Now from the graph, you could probably spot that 90, I mean, it's all the way up here somewhere, there's actually going to be two parts to it. There's going to be two answers to this. So let's try. 4 take away x equals 90. And so that tells me x is equal to minus 86. Or maybe up here, that x squared add 9 equals 90. So x squared equals 81. And x equals plus or minus 9. Hang on a minute. Minus 9? No, minus 9 would be down there. So we only want an x equals 9, positive 9 from that half there. So there's the 2 points where it meets, one there and one there on the graph.